Good afternoon, students. Good afternoon, students. Kindly settle down quickly.
Namaste, ma'am.
All the numericals we are using test room will be from what she is teaching. Other than that, nothing will be asked. It's in your hands to listen to it or play and ask. Yes, Darshan, inform her that we are ready. You can start the session.
Ma'am, we are ready, ma'am. We can start the session now.
Okay. But I can still see so many students moving from here to there. Please settle down quickly. So in the last class, we understood that as we are growing, moving from class 10 to 11th, we have to update our knowledge about the orbits. We need to know more about the structure of atom. In that concept, we said till class 10, you have heard only about this term which is written as orbit, right? We always believed that electrons are filled in orbits according to Bohr-Bury's rule. I believe all of you remember that, or else I'm going to give you a quick recap of that it is 2n square rule. It has two parts. One is that maximum number of electrons in any shell is given by 2n square, where n is the number of shell. If the number of shell is 2, we will say it will have 8 electrons. And the second part of rule was also there. Can you all quickly sit down? I'm repeating what I have said till now, and I believe all of you have settled now. So I was saying that in last class, we understood what is inside an atom. An atom has a proton, electron, and neutrons. And electrons are filled in various orbits as per the understanding given to you in class 10th. They were being filled according to Bohr-Bury's law or Bohr-Bury's rule. The first part of Bohr-Bury's rule says that maximum number of electrons in any shell or orbit is given by 2n square rule, where n is the number of shell. For example, if we are talking about the second shell, then that will have maximum of 8 electron. There was another part of this that maximum number of electron in the outermost shell cannot be more than 8, right? So that was done in the previous classes, talking about how electrons are filled in different orbitals. Now, what we are going to understand, we are trying to understand is that what is an orbit and what is an orbital. Anybody knows what is an orbit and orbital? Don't read what is written on the board or the whiteboard precisely. Just tell me if you understand how is orbit.
Negatively charged cloud.
Any other idea? Okay, let me explain it to you. See, when I say, let us draw the atom of sodium, atomic number 11, configuration is 281. Now, till now we have been drawing, assuming it is a nucleus. This is the first orbit. This is the second orbit. And this is the third orbit. Now, if you have to find the electron, what you have to do? You have to look into the entire area, which is the third orbit area. Right? If I have to find the electron, I have to flush out or look out for this electron in this entire area. That will be a lot of effort. And again, it will not be a precise position. Like if you have invited your friend to your home for a birthday party, right? And you do not tell him, you just tell him the probably street name. You have told him that you live on XYZ street, but you have not told him the house number. Then how will that person reach to you? You have to give him a precise address. Nobody can reach to your home without a proper address. And the address has to be narrowed down to as much small or a concise or a precise detail as possible. Similarly, therefore, what the scientists did, instead of searching for the entire area of this orbit, they divided that each orbit into smaller parts, which is known as orbital. Now, the difference between the orbital and egg-rack, as you can see here, you must have seen at your home or school anywhere that the egg-rack has 12, 16 or 20 spaces there to fit in eggs into them. The only difference between this example and orbital is that orbitals are of various shapes and sizes, right? We'll take them up in the next few minutes. They can be S, P, D, and F. S is the smallest and F is the largest one, right? So what we are doing, theoretically, we are saying that if orbit is this much long or this much large, we are dividing into different type of orbitals. We can say this is S orbital, this one is a P orbital, this one is a D orbital, and this one is a F orbital, if we want to think it in terms of a two-dimensional space. But we must remember that although we continue to draw the structure of atom in the spherical orbit, practically speaking, a spherical orbit does not exist. I will tell you the reason. That it is a certain part of a physics is there. Then when there is a charged body is revolving around another charged body, then the force of attraction develops between them, right? That means if there is a positive charge at the center and the electron is revolving around it on this path, an electron is revolving, both of them are oppositely charged, they will be attracting each other. As a result, the size of the circling orbit will keep on decreasing. Say after time t, the size of orbit will shrink to this much. Ultimately, the electron will fall into nucleus. If you are taught about the Rutherford model, it is the drawback of Rutherford's model, right? Then that which says that although we still keep on drawing them spherical, because elliptical orbits are very difficult to draw. So we continue to draw them spherical, But whenever a question comes, what is the shape of an orbit? We always need to say it is elliptical. It is not circular. Is this point clear to all of you? So you need to respond me because if this point is not clear, the later on points will also not be that much clear to all of you. Please find a mic and speak.
Yes, ma'am.
Okay. Now, can you see my hand? I have an onion ring and I'm trying to remove different parts of it. Is it visible to the students? I'm not able to hear whatever you are saying.
Ma'am, it's not visible.
Okay.
Now
can
okay,
you...
ma'am.
Okay. Now, this is one onion circle, right? And as you know, onion is made up of concentric rings, right? Please try to understand that assuming this one is orbit, right? Orbit is in horizontal plane. I believe you can see this, that or I have kept
Yes,
an orbit. Let's say it's a fourth orbit. It is in the horizontal plane, right? Now, where should I place the orbital? As I said, orbitals are part of orbit. You have a big society and you have many houses. They are stacked or placed one over the other above. Similarly, what we are trying to figure out here is that where is an orbit and where is an orbital? Orbital are a smaller part of an orbit. Now, if I talk about the S orbital. S orbital is nearest to the nucleus and in the central part of it, right? In the center part of it, you will find the S orbital. And remember, it will be perpendicular, right? And I will take a bit larger one. If this is the P orbital, it will be placed next to S in this perpendicular fashion. Is it clear now?
Yes, ma'am.
Okay. Talking about the D and F, their circles are still larger. So what you will see, that P and D, they will be still outer and larger like this, right? You can come to screen, closer to screen with the ma'am's permission to see it if it is not clear to you.
It's clear, ma'am.
Okay. So let's try to make it in PowerPoint presentation to share the PPT and continue learning. I believe you can see the screen now. So now if somebody asks me to draw an orbit and orbital within an atom, what we have to do? Yeah, what we have to do? We will be drawing the orbit like this, elliptical as much as possible. Let's assume this is our fourth orbit. And as I told you, the the orbitals are, we have 4 orbitals. S, P, D, and F. The S is nearest to nucleus. And F is furthest. So if somebody asked me to draw them, I will be saying that this area, let's say this is the central part, it is of s orbital. The area next to it is of p orbital. Then we have the area of d orbital, and then we have the area of f orbital. Is it clear to everyone that where is an orbit and where is an orbital?
Yes, ma'am.
Okay. Now, when we talk about, now let's see which orbit has got how many orbitals and how do we count them further. So, or before that, let's understand what is the difference between an orbit and orbital. Please remember, orbit is a fixed path, as you have learned in class 9th and 10th. Orbit is you can imagine orbit to be a concrete path, like we have roads. Again, I'm saying imagine. They are not there, but definitely imaginarily they can be seen as a circular path on which the electron moves. If I take this, the image we have drawn, the electron, the first 11th electron of sodium will be moving only on the purple circle, right? But what is an orbital? I remember somebody in the beginning of the class said electron cloud. I just want to make some improvement in that definition. Please remember, the orbital's definition is very important. It can be asked in a 1-mark question. Orbital is not a concrete road like orbited. It is just a probability where the finding of electron can be maximum. That means, see, between 320 to 420, what are the 11th class students supposed to be found at? Where can somebody catch you? Somebody can definitely catch you on Thursday evening in this classroom. Maybe 3:15 to 3:20 is your break time. You can be found outside this class. That is finding you between timeline 3:15 to 3:20, where it is maximum. It is maximum that you will be found in, say, near a water cooler, or maybe chit-chatting in any corner, or may have gone to visit the canteen in your school, right? So that is what we mean. We are not fixing your position. You may be found chit-chatting with your friends, or you may be found having something to eat or drink. But the probability is maximum. You will not be found in this classroom. That's for sure, isn't it? So that is what we say. What is an orbital? Please remember this definition. It is the area where the probability of finding an electron is maximum or highest. Another difference between them is, as I told you, it's a 2-dimensional space. Remember, I told you it is in the horizontal plane, whereas orbitals are always found in a 3-dimensional space. I believe it is clear. Most of the time in school exams, we are asked to write the two differences between orbit and orbital. I believe it is clear now that orbit is a fixed path, whereas orbital is just a probability density, where possibility of finding an electron, which can be considered as electron cloud or a negatively charged cloud, is maximum. Then the second point is very easy to understand. It's a 2-dimensional space and it is a 3-dimensional space. Moving on. Different orbitals have different shapes, right? It's time to understand what is their shape. And as we define orbitals as the place where the probability of finding an electron is maximum, it is represented by probability density, or this is called as psi. This is psi square, right? So it has, if you study to BSc or some even higher classes, the study of structure of atom is involves a lot of mathematics. In class 11th, it is a bit simplified. We'll take it up later, but we will not be going into the derivations of it, right? So if somebody said what is psi square, it is the probability where it is the representation of probability of finding electron, or it is a probability density. Moving on, we say, now we have to understand what is a node. Note that if I say s orbital is spherical in shape, right? Within the boundary, within this circular area, there must be a place where the probability of finding an electron is 0. And that is called as node, right? Please remember, it's not outside orbital. It is within orbital, a place or the area where the probability of, yeah?
Can you move to previous slide?
Okay.
Two minutes to copy.
Okay. I can see a lot of noise in the class. Have you noted down?
Yes, ma'am.
Okay. Now we were discussing what is a node. Within the orbital, if I say this is an s orbital, there must be a node. Node, if I draw it like a dotted, yeah. Are you saying something to me?
Previous time one. Yes.
Means I said there are two names alone. They are not doing it. Everyone together laughing there. Is it a funny class going on here? Anything interesting or playing?
Please tell me once you are done. Please do not make any noise. Focus on copying down if you want to copy down.
Okay, ma'am.
Done?
She can hear you talking, making noise. Those who want to talk, please feel free to move to the auditorium. Please don't stay here and talk. This is the last warning.
Done or not done? Okay. Okay. Now, moving to the next concept, what is a node? Node is an area within an orbital where the probability of finding an electron is 0. See, this is an s orbital. The area represented by dotted line can be said to be a node. That you will not find an electron at this particular place. Then the question comes, what is the role of node? Right? We will answer this question after understanding the shapes of different orbitals, what are their names and why they are called so. We have total of 4 types of orbitals in our syllabus. You may read in certain books as G orbital also, right? But we need to focus only on S, P, D, and F. Here, S, they do not have this meaning, whether sharp, principal, diffuse, or fundamental. It's just to indicate the name of S orbital is obtained from the word sharp, P is principal, D is diffuse, F is fundamental, right? Now, what is their shape? The shape of S orbital is, as I told you, it is spherical. Now, what is the shape of P orbital? It has 3 dumbbells. This is one dumbbell. This is second dumbbell. And this one is the third dumbbell. Similarly, for d orbital, it is made up of 5 dumbbells. F is made up of 7 dumbbells. Is it clear? This has to be, I will say, remembered, or we have a word called as marked up. Even any time of the day, you must remember an orbit can have 4 type of orbitals or subshells. They are S, P, D, and F. S is spherical in shape. P is made up of 3 dumbbells. D is made up of 5 dumbbells. F is made up of 7 dumbbells. Is it clear?
Yes,
Is
ma'am.
it clear? Okay. Now, this is the shape of an S orbital. Most of you or all of you must be having a mathematics as your subject, where you can see that it is having X, Y, and Z axis. And in the sphere, a sphere has no directional properties. That is, it can be the electron density is equal in all direction for S orbital. We say it is a directionless orbital, right? Because it's similar from all the sides. You can place it in any way. Now, here comes the role of nodes. Before that, let us understand if we number our orbits. I will take up another blank slide to explain this. Please pay attention to it very carefully. It is a relationship between orbits and orbitals. And number of electrons. Please note down, S orbital can have maximum of 2 electrons. Then P can have maximum of 6, D can have maximum of 10, and F can have maximum of 14 electrons, right? Then we come to if the orbit number is 1, according to 2n square rule, how many electrons it can have? I believe you remember it is 2. If you substitute n is equal to 1, it will have 2 electrons. Orbit number 2, it will have 8. 3 will have 18. And 4 will have 32. Till this point, is everything clear to all of you?
Yes, ma'am.
Okay. Now, how many orbitals each one of it is going to have? The S orbital has 2, P has 6, and D has 10, and F has 14. Now, what we have to do? In the first orbit, you have to accommodate only 2 electrons. So, in terms of orbitals, I will say the first orbit will have only S orbital. And that orbital will be named as 1s, indicating that it is S orbital of first orbit. Now, talking about the second shell or second orbit, it can have, as we have written, maximum of 8 electrons. So that means, as I told you, what do you need? You need 1s and p orbital. To accommodate, S will have 2, P will have 6. And they will be named as 2s and 2p. Is it clear?
Yes, ma'am.
Okay. Now moving to the third, as you have understood, third will have S, P, and D. And they will be named as 3s, 3p, and 3d. Similarly, 4 will have all S, P, D, and F. They will be named as 4s, 4p, 4d, and 4f. Right? I believe it is clear to you. Now, a question
Yes,
comes
ma'am.
to the mind. What will be the difference between 1s and 2s? As I have told you, s is spherical in shape. So that means 1s, 2s, 3s, 4s, or whatever, 5, 6, 7, 8. You have learned, there is a chapter of periodic table where we will learn that elements till 8th shell are complete now, right? So that means how many S we can have? We can have 4s, we can have 5s, 6s, 7s, 8s. Primarily, all of them are going to be spherical in shape. But there will be a difference in size. 1s will be the smallest one, 2s will be slightly larger, 3s is still larger, and the size will continue to grow. Right? How will the size grow? To answer that, we have nodes. The 1s orbital does not have a node. Right? For s orbital, number of nodes is given by n minus 1. I'm writing it that for s orbitals, number of nodes is equal to n minus 1, where n is the number of orbit. That means number of nodes in 1s orbital will be 0. 1 minus 1, that will make it as 0. For second orbit, it will be 1. Here 2, 3, 4, 5, 6, and 7. I am repeating or recapitulating this slide that we have understood the relationship between orbits and orbital. How many orbitals or which type of orbitals an orbit will have is clear. The first orbit will have only 1s orbital, second will have 2s and 2p, third will have 3s, 3p, and 3d, and fourth onwards, every orbit will have 4s, 4p, 4d, and 4f orbitals. It is based on the fact that number of electrons in an orbital, that is s will have 2, p will have 6, d will have 10, and f will have 14 electrons. Then we have understood how and why the shape of the orbitals will increase, size of orbitals will increase. It will be increased with the number of screens, or we call them as nodes, where the probability of finding an electron is 0. If I can if I draw the 1s or 2s orbital, if you are done, I will move to the next slide. Done and understood.
Yes, ma'am.
Okay. So here you can see the difference in sizes of 1s, 2s, and 3s orbitals. You can see in 3s orbital, I have drawn, or in the picture you can see 2 nodes are there. In 2s orbital, you can see 1 node, and 1s orbital does not have any node. Right? Now, moving to the p orbital. Now, as I already told you, the p orbital is dumbbell shaped. In which direction will you find the dumbbells? That is, you will find one dumbbell in x direction. As you can see, this one is in z, and this is called as on pz axis, right? This one is on x axis, it is referred as px. This one, the direction of dumbbell is in y direction, so this is referred as py. All three of them are collectively shown in this picture. Picture is just a color representation. Orbitals are never associated with a certain color. Is it clear? That p orbital will have 3 dumbbells, one in x direction, one in y direction, and another one is in the z direction. In the exam, you may be asked to draw the image. So this is a this is our image. Once I will draw it for you, you have to draw it like this. The second one is like this. And the third one is like this. Right? This is what you may be asked to draw. Coming to the second point, notes. It will have n minus L minus 1. This point, I have just put it here so that we remember. We will do it after we do the quantum numbers. In this chapter, there are certain topics in which they follow the story of a chicken and egg. Who came first, the egg or the chicken? So this is one of that concept. We will take it up later shortly. Now, coming to this degeneracy concept or the degenerate orbitals. Again, it's a good 1 mark question. What is a degenerate orbital? That means px, all the 3 orbitals, px, py, pz. Like you have 3 identical twins. They will have identical properties. Or a bit easier example. You go to buy NCERT class 12th, class 11th book 1. 3 different students will get the same book. Similarly, we cannot say that px is more energetic or py is more energetic or pz is more more reactive. So that means all of them are equally empowered, having equal amount of energy, or they have same amount of energy. Such an orbitals are called as degenerated orbital or degenerate orbitals. Is it clear?
Yes, ma'am.
Okay. Now talking about the d orbital. See, in my opinion, only we need to focus on this particular, the last one, dz square. In d orbital, as I have told you, it can have maximum of 10 electrons. That is 2 electrons in each dumbbell. Right? It has got 5 dumbbells that we must remember. We have done it earlier also. So if it has 5 dumbbells, so it will have 10 electrons. If we can draw one of them, it will have 1 electron, let's say here, and 1 electron here. The electrons always move in the opposite direction. We will say just by chance. I'm putting it as clockwise. There is no rule to say that first one will be clockwise or which one will be clockwise. And the other one is anti-clockwise. Whenever we talk about motion of electrons in chemistry, we talk only about clockwise and anti-clockwise. I believe you understand. Clockwise means as your clock moves, and anti-clockwise means in the opposite direction. Right? I was saying that we must remember the last one, dz square. You can see only it is having only 2 lobes, or we say it is having only 1 dumbbell. So that is the 1 mark question. Name the d orbital which is having only 1 dumbbell or which is having only, we call them, this is 1 lobe and this is the second lobe. Or we can say that each dumbbell is made up of 2 lobes. This is lobe 1 and this is lobe 2. Right? What is the meaning of dxy here? You can see there are 2 orbitals. There are 2 dumbbells rather. One on x-axis and they are in between x and y-axis. Similarly, x and z, y and z, x square, z, y square, we do not have any explanation. The only important orbital on which you can be asked a question is dz square. Right? Is it clear? Should we move ahead?
Yes, ma'am.
Okay. Moving to the F orbital. F, as I told you, F's structure is not mentioned even in NCERT. But just for the information's sake, I have put it on here. There is no need to copy it down. We just need to remember that it is made up of 7 dumbbells. Right? And 7 dumbbells means it will have 14 electrons. So now, can somebody tell me how many electrons can be accommodated in p orbital?
Ma'am. 6, ma'am.
Correct. Okay. Now we will understand. Before I start Aufbau, can somebody tell me that have you been taught about Aufbau and all rest of the principles for filling the electrons?
Yes, ma'am. Done, ma'am. For
Done.
11 weeks not taken.
I didn't understand.
Ma'am, only 11A they took, ma'am. 11B they didn't start.
Okay. Means you are saying that you are 2 section students are sitting here. One section has been taught and other has not been taught, right? Okay. See, the students who have been taught must be familiar with this. Now, can you tell me what is the name given to this diagram?
Yeah.
Or before that, tell me what is Aufbau meaning? What is Aufbau? See, for filling of electrons, it's not that what we were doing in orbits that you apply to a square rule. When filling electron in orbitals, we'll be using 2-3 rules. We'll be using Aufbau majorly. Then we will be moving to Hund's rule. We'll be talking about Pauli's exclusion principle. We'll be talking about N plus L rule, right? The first one is Aufbau. Can somebody tell me what is the meaning of Aufbau? Please remember, in most of the scientific terminologies, the names are taken from the name of the scientist, but Aufbau is a German word. Please note down. May not be important for your school exam, must be, but it is important from the perspective of the competitive exams, right? It is a German word which means building up. Right? And it gives you the order of filling of electrons in orbitals. Now the section whose students have been taught about it can just tell me what is this diagram called as. Can someone who has done this topic can explain it to me or to the other students? Please do not discuss.
Question, ma'am.
What is the name? This is a diagram or this is the method of filling the electrons in the different orbitals, right? Now, can someone tell me what is the name given to this particular diagram?
Aufbau principle.
Aufbau principle is correct. That is the rule or that is the law, right? But is there any name given to this diagram? Let me tell you, this one is called as Euler diagram. You must pick up the habit of knowing as many names of a particular thing as possible. In case you get a question paper from the outside and they ask you to draw the Euler diagram. So once you know what it is, then you will be able to draw this one, right? Now I will tell you how to draw this. Any the students of section where this topic is covered, do they know how to draw this?
Ma'am,
Yeah.
ma'am, it's not clear, ma'am. You can write little green.
Okay, I will draw. Okay, I will tell you how to draw it with reason. See, as we have just discussed, the first orbit is divided into only one orbital, that is 1s. Please tell me at the point where you are not clear, because every time repeating it we have to go back to point number 1, right? We have just done that first orbit has 2 electrons. It will have only 1s orbital. Now the second orbit will have 2s and 2p, because second orbit can have s and can accommodate 8 electrons. So as I told you, for the benefit of the student, I'll be writing S2 means S can have 2 electrons. P6 means P can have 6, and D10 means D can have 10, and F14, that is, it can have 14 electrons. Now, moving to the third orbit, we said it is 3s, 3p, 3d. Again, 2 plus 6, 8, 8 plus 10, 18. From fourth onward, we'll be writing 4s, 4p, 4d, and 4f. Fourth onwards, we'll be writing all of them. Then we'll be writing 5s, 5p, 5d, 5f. Then 6s, 6p, 6d, 6f. Similarly, we will be drawing 7s, 7p, 7d, 7f. Now, almost till this point only, the element have been discovered. We can have 8s, 8p, 8d, 8f also. But we need to know, as we have discovered only 118 elements, we have to fill only 118 electrons.
Ma'am,
right? Yeah.
ma'am, after that, the range will be decreasing, ma'am. But how come you will write 4s, 6, SPD after the 5, 6?
I didn't get your question. Can you please repeat it?
Ma'am, how 6F came, ma'am?
How is 6F? See, it is we are trying to understand how to draw how to use Aufbau principle in filling the electrons. And I believe you are asking whether 6F will be there or not, isn't it?
Yes, ma'am.
6F will be there. See, theoretically it is possible. You will have 6G also if you want to know more about it. It will be there. See, it is a need-based things. Suppose I have 4 guests at my home. I'll be cooking on. I may be having, let's say, 4 kgs of let's say, paneer at my home. But will I be cooking 4 kgs? No, because for 4 guests, 1.5 kg is sufficient, right? Similarly, this is the maximum possibility where an electron can be accommodated theoretically. Like you have your house, you have ladders in this. If you have a 4-story building, you will have a ladder till 4th block only, 4th floor rather only, right? Nobody will be so senseless to have making the ladder for reaching to the 5th floor, which does not exist. Same way we are saying the construction is done. Atom is having the orbits, orbitals are intact. It's up to them how many they want to fill. But the filling order will be decided by Aufbau principle. Have you got the answer to your question?
Yes, ma'am.
Okay. Now, this is what we have written as a raw structure. Now we will understand how the electrons are filled. For this, let's just please follow what I am saying, that whenever you have to draw the diagonals like this, and the diagonals which are going downwards will be cutting the name of the orbital. Say 1s is orbital's name, 5d is the name of the orbital. So what I will do, I will draw it from here. This line will be cutting 1s. Then what I will do, I will draw a line which will go upwards. And this line should not cut anyone. Then when it is going down, it will come 2s. It will cut 2s. While it is going up, it will not cut anything. Then it will cut 2p and 3s. Again, while going upwards, it is not supposed to cut anyone. Then it will come down, cutting 3p, then 4s. Then when you move it upwards, it will not cut anyone. Then it will cut 3d, 4p, 5s. Again, the line going upwards is not cutting anyone. Then it is coming down, cutting these orbitals. From 6s, it will move upward and will not cut any orbital. Moving down, it will cut all these, right? Then going upwards, it will not cut anyone. This is how you have to draw it, right? Is it clear, or should I draw it again?
Clear, ma'am.
Okay, now we have to follow the line which we have drawn. So 1s, and after that what we have, which orbital it has gone, 1s, then 2s, then 2p, then 3s, then 3p, then comes 4s, and then comes 3d, then 3d, sorry. Then 3d is followed by 4p, 5s, and it moves on. So is this clear to everyone? The students who have studied it and the students who have not studied it? Both of them?
Yes,
Now
ma'am.
Okay, can you draw it at your own?
Yes, ma'am.
Okay, good. This is the order of increasing energy of sublevels or orbitals. I remember it. See, if you ask me anytime, I remember it like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. I remember only till it, right? Most of the time, your problems will be solved with this, if you remember it in this way. Of course, you are a student, so you have to be ready for 7F also. In this particular case, I have included G also, but please do not do this. You draw your own Euler diagram, this one. We should not go to that extent, right? And this is, yeah.
Can you show previous slide, ma'am?
Which one?
Order increasing energy.
Okay. I think you are asking for this one. So, but
Yes,
please,
ma'am.
okay, but please don't try to remember those G wala funda. Don't do this.
Okay, ma'am.
Delete it from here. Now, in the meantime, can students write the configuration for atomic number 27? in terms of SPDF. It's there in front of you, but I believe some of the students must have remembered it. So can you write it?
Ma'am, can you repeat the question again, ma'am?
Atomic number 27. Write the orbital configuration. Now, please do not discuss among yourself. The answer itself is on the board. You just have to do it only till atomic number 27.
Completed, ma'am.
What is the configuration of element having atomic number 27?
D block. 1s square 2 is
Yeah, please carry on.
1s2 2s2 and 1p4 3s2 2p4 2s2
1p4.
1b3.
Okay, hold on. From where you got that 1p4? 1s2, 2s2, and after that?
Ma'am, 1p3, ma'am.
Where is 1p3 in this? What is 1p3? Please explain to me.
Ma'am,
Yeah,
can I say, ma'am?
yeah, definitely. Please speak. I'm waiting.
3s2, ma'am.
1s2.
1, 2, 2s2,
Yeah,
2p6,
yeah,
3s2,
yeah.
3s6,
3s2. After that, 3s2. What do you say? See, the order is on the screen. Dear student, please complete what you were saying. 1s2, 2s2, 2p6, 3s2, and after that? What should I write after 3s2?
3p6, ma'am.
Okay, 3p6, right? Then?
4s2, ma'am.
Okay, correct. Then?
3p7.
Correct. That is the correct answer. What you have to do. And what's your name, dear student?
Zeril, ma'am.
Okay, good. Keep it up. See, for the benefit of other students, before winding of the class, let us understand that we have to follow this order. We have to omit G from here and we have to follow it. Right? 1s2, 2s2, 2p6, 3s2. Can somebody stand up and tell me who said that 1p3? There is some conceptual error in it. I wish I can clarify to the student. Instead of discussing among yourself, please ask me or tell me.
Little bit confused.
See, since I believe ma'am is also not in the class, who can help me out. When you are saying 1p3, I have shown you, I have told you that the first, it's a need-based requirement. The first orbit, according to Bohr-Bari's law, can have maximum of 2 electrons. So that means it requires only one s orbital. It does not need at all, right? Everybody wants to conserve the energy. It does not need, so it does not have one p orbital. I don't know, I'm not too sure. I heard 1p3. More importantly, if it was a p orbital, it can have 6 electron. It will never have 3 electron if you have enough electrons in that atom, right? So 1p3 is not possible. In fact, that is one particular question, that why second orbital does not have d orbital. Second orbit will never have a d orbital because it has to accommodate only 8 electrons. And the 8 electrons can be accommodated in 2s2 and 2p6. Right? So that is the reason 1p does not exist. Now coming back to the example of atomic number 27, in the end we have 3d7 because all the electrons are being consumed there. Is it clear to everyone, or do you have any other doubts? Any doubts?
No doubts, ma'am.
Okay. Now, your homework is that you will be writing the configuration for atomic number. I'm giving you, let's say 37, then 59, 24, and 29. We will begin next class with the electronic configuration of these 4 elements, 37, 59, 24, and 29. I'll request sir or ma'am, whosoever is there, please ensure that students have noted down the homework and ask them to do it before the next class. Okay, so we'll wind up the class with this and we'll be taking up from here in the next class. Thank you and have a good day.
Thank you, ma'am. They must have noted the homework. Thank you so much.
Welcome.
Yes, make it fast.
Only